Okay, now we're going to apply our enthalpy idea to, instead of a chemical reaction, or it's more like a physical change, or we're going to apply it to dissolution, and you can argue whether that's a chemical or physical change till the cows come home. Anyway, so the enthalpy of dissolution is the energy change when something goes from its undissolved to its dissolved state, okay? Also known as heat of solution or molar enthalpy of solution, all meaning the same thing. The one that I tend to use and most common is heat of solution, okay? So there's both positive and negative values for heats of solution out there, okay? So you can dissolve some things and it'll be an endothermic process, and you can dissolve some things and it'll be an exothermic process, okay? Most dissolutions of salts, so ionic solids in water, are exothermic. Most of them, not all of them, most of them. But most of them are very slightly exothermic. So they're not huge, okay? They're not huge values like combustion reaction values and stuff. Some dissolution of salts are endothermic, but only some, okay? All right. It's this simple because I'm just jumping straight to a problem here. It's just we're applying the same enthalpy change questions to a dissolution equation now. Okay, so the dissolution of glucose in water is endothermic. So here I've got 1 mole of solid glucose and then 1 mole of aqueous glucose, and my enthalpy change is positive 11 kilojoules per mole. So it's endothermic, just slightly. How much heat is absorbed when 12 grams of glucose is dissolved in water? Okay, so all we need to do is 12.00 grams converted over to moles of glucose. So let's divide it by 6 times 12.01 for carbon, plus 12 times 1.008 for hydrogen, plus 116 for oxygen, will give us how many moles of glucose we're going to dissolve. All right, let's put it in our calculator. 12 divided by bracket 6 times 12.01 plus 12 times 1.008 plus, it's 6 times oxygen, isn't it? Why did I say 1? I was back on that alcohol problem, wasn't I? Plus 6 times 16.00. That's better. Wouldn't it be embarrassing if I couldn't even calculate a molar mass? Okay, so I've got 6.66 times 10 to the negative 2 moles of glucose. All right. How much heat is absorbed when I do that? Okay. So I'm looking for energy, and I've got my enthalpy, which is kilojoules per mole, and I've got mole, so what I'm going to need to do is times them so my moles cancel. Okay, and I'm just left with the unit that I want. All right, so let's do that. So the energy absorbed equals my 11 kilojoules per mole from the question, times it by my number of moles, 6.66 times 10 to the negative 2 moles. Okay, I've still got the previous number in my calculator, so multiply it by 11, and I get 0.732 blah 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 kilojoules. I could leave it there, but I might. How many two significant figures from the 11 kilojoules, so I might just call that 730 joules to 2 sig figs. All right, and I might put a positive in front. That makes me happy. I can go, oh, positive, endothermic. Okay, example 2. Same type of question. Oh, no, well, we've got a heated solution here. So we've got potassium nitrate going to potassium and nitrate ions separating in aqueous solution. Here we've got an endothermic process, as well. positive 35 kilojoules per mole. How much potassium nitrates need to dissolve in 1 liter of water to cool it? Ooh. Cool it from to 2, okay? So I need, if I'm talking about something cooling, I need, or heating, Q equals MCAT, okay? So what I'm going to do is the heat absorbed by the solution I'm going to try and quantify, okay? So the mass, okay, well, the mass of the solution is pretty much going to be the mass of the water. That's all we can put in. So that's 1, or what I might do is keep it as 1.00 kilograms, okay? Because density of water, 1 liter, 1 kilogram, okay? That's around 25 degrees Celsius. We're good enough. Times by the specific heat of water from our data sheet, which is 4.18 times 10 to the 3. As joules. Joules per kilogram per Kelvin. What a duffer. Joules per kilogram per Kelvin. Okay, notice how I put kilograms, so the kilograms are going to cancel. Okay, and I know that's not the most user-friendly specific heat capacity value, but it's the one that's on our data sheet, so let's stick with it. Okay, delta T is going to equal 24.0 minus 20.0, which equals 4.0 Kelvin. Okay, so the heat that we need to cool this from 24 to 20 equals, well, 1 times 4.18 times 10 to the 3 times it by the 4 Kelvin equals 16,720 joules. Okay, so we need that many joules. All right, let's convert that over to kilojoules, because we're going to have to combine it here, and it's 35 kilojoules per mole, which equals 16.720 kilojoules. Okay, so how much do we need? Okay, well, our mole that we're trying to find out how much we've got is going to equal our 16.720 kilojoules divided by our 35 kilojoules per mole, and that's going to give us, kilojoules is going, oh, what have I written there? How embarrassing. Okay, so kilojoules is going to cancel top and bottom, and moles is going to drop up the top. Okay, so 1670 divided by 35 kilojoules per mole. Oh, you know what I've done? I just put it in my calculator and stopped and paused because I've got 477. It's because I didn't convert because I had my answer in joules still. 16.720 divided by 35. Ah, that's better. 0.4777 moles. And it's saying how much potassium nitrate. So let's convert that over into mass. So it's going to equal our 0.477 moles times it by our molar mass, our grams per mole for potassium nitrate. So potassium is, I always forget, 39.10 grams per mole. So we need 1 potassium, 1 nitrogen. 1 nitrogen is 14.01, and 3 oxygens is 16.00 grams per mole. Okay, put it in my calculator. 39.1 plus 14.01 plus 3 times 16 in bracket, and I get 48.301 grams, and I can only put it to 2 significant figures from my kilojoules per mole, and also my delta K was 4.0 K. So that's going to be 48 grams. So I need 48 grams of potassium nitrate to dissolve in the 1 litre of water to cool it from 24 degrees down to 20 degrees Celsius. Alright, there's some extra problems there on the worksheet for you to do.